Welcome to clickmyproject.com. Let's discuss on the paper Design of New Unitary Transforms for Perceptual Video Encryption. In this paper, the main aim is introduction of a perceptual video encryption. It was definitely very important for video-based services over networks. This encryption criteria are of two folds. The first one is the video signal is encrypted to a certain extent so that only the customers, those who are paid for the service, they can obtain the high quality version. The second one is some video contents are still visible but at a much lower quality for those who did not pay. The second criteria is coming under perceptual video encryption. In our proposed work, we are going to embed the encryption into the transformation stage within the video encoder. The key in this encryption framework was to design some new unitary transforms that can produce a very similar RD performance as DCT does when used to encode the residual signals. Based on the DCT's flow graph structure, we recognized that four transforms used were rather close to each other. In our system, we are going to design some new transforms that are farther from DCT but offer exactly the same coding efficiency. So we plan to improve the encryption performance by introducing such new unitary transforms. The principle of designing these transforms still follows the plane-based rotations in a high-dimensional space. According to the encryption key, one out of these transforms was then selected for each row or column in every block so as to perform the encryption. By doing some experiments, we can show that the transforms provided a sufficient level of encryption better than what we had done in earlier days. Now let's discuss on the data flow diagram. The first block is nothing but loading the given input video. After loading this video, the next step is we have to convert the video into frames. Frames are nothing but still images. With the help of the mmReader function, we can convert the input video into frames. Following this conversion, the next thing is we have to introduce the new unitary transform. These transforms were derived from the 4-point DCT's flow graph structure by selecting a different set of rotation angles in terms of pi by 4 or 3 pi by 8. A sign flip on the DC component has been adopted in our algorithm. Come to the next block. It is nothing but key generation. Key is generated by means of random permutation. It is nothing but a permutation containing a fixed number, that is n, of a random selection from a given set of elements. It constructs a vector of random real numbers and uses them as keys to records containing the integers 1 to n. Now we will do the encryption after getting the transformation coefficients. Suppose if you want to display the encrypted video, that means perceptual video means, the next step is do the inverse DCT. It is nothing but multiply with the inverse of DCT matrix. The twiddle factors are the complex conjugates of the DCT factors and the reorderer is applied at the end rather than the beginning. Finally, we got the perceptually encrypted video and it will be displayed in a separate figure window. Come to this row. After the encryption process is over, next we do the quantization. Quantization is nothing but reducing the number of possible values of a quantity, thereby reducing the number of bits needed to represent it. Here, following this quantization, we do the encoding process. At the end of this encoding, we obtain a bit stream. That means it contains zeros and ones. Arithmetic encoder is used to generate the encrypted bit stream. So the output of this encoding block is nothing but the generated bit stream. Following this encryption process, If we want to reconstruct the original video as it is means, in that situation you have to do the decryption. Decryption is nothing but again you do the reverse process as what we have done in the encryption process. That means once again take down the inverse DCT and transform the coefficients once again into the intensity values. Now the reconstructed video will be displayed to you. Now let's see the execution of our proposed implementation. And this is the main file main.m. Select the option Run File. File dialog window will be shown to you. Select the test1 video. The input video will be displayed to you. Following this, the frame conversion is going on. Each and every frame is displayed one by one. In a single figure window, we can show all the frames using the subplot function. The frames will be collected in a data structure named as shell array. That will be utilized for our further process, encryption, encoding and decryption. Now this is the encrypted video display, perceptual video encryption. Now this is the reconstructed video after the decryption. Now we come to the display of encrypted bit stream, zeros and ones, that will be displayed in this command window in a sequential manner. For all the frames, the encrypted bit stream will be shown to you. The display of this encrypted bit stream, it will take much more time. So in future we can use some parallel processing for reducing the execution time for this display. We can deliver this work to a number of MATLAB processes. By doing so, we can easily display the bit stream within a short duration of time. Now the bitstream process is completed. These are all the performance analysis graph. Now see this is the quality measure, the computed MSE and PSNR. MSE is the mean square error, PSNR peak signal to noise ratio. For each and every frame, it will be displayed here. Now see the PSNR value, it is 53. So we are obtaining a good quality reconstructed video. The corresponding PSNR values are plotted as a graph. The x-axis, it represents the frame index, and nearly 50 frames we have in this video. For each and every frame, the obtained PSNR value is plotted here. Now this is the MSE graph, mean square error. For all the frames, the MSE value is computed and displayed here. By seeing these graphs and analysis measured, we can come to a conclusion. Our system, proposed system, will yield the best performance while doing the perceptual video encryption. Thank you.